go. All right. Thank you all so much for being here and letting me kick this off. I'm so excited to talk with you all about this. I'm very excited about this theme. As you can tell by the hat, I brought my own. Now I have two. If anyone wants one, come find me after the conference or after I'm speaking. It's yours. Love the theme. Love all of this. Thank you all for being here. Today I want to talk about a project called Pika. And I want to start off with a question. Now, I should explain, I'm actually trying out something new. I'm using a slide bundler. It's really powerful, it's really cool. Only problem is I just have to compile every time I change slides. You guys, we won't even notice it. It's really seamless. Uh-oh. Is that the bundler or is that my mouse? Okay. Right, where was I? Question. Who here has ever used Webpack before? Right, that's a lot of hands, right? It's an essential part of web development today. Really foundational piece. Who here has ever had trouble with Webpack? The exact same set of hands, right? Trouble with the configuration maybe, or even just getting started, what any of it means, how it works. Really powerful tool that's also very complicated and hard to get perfect, hard to really configure at that level. All right, next question. Right, just give it a second. Yes, who here has ever seen one of these before? Awesome, that's great. This is a bundle analysis. So if you are using a bundler, it's really good to know kind of what's going on in production. Is there anything maybe, basically it just gives you a really nice overview by analyzing your bundle and telling you what's actually in each one. Now, if you've never done one of these before, I definitely recommend you do, because very often the first time you do it, it looks a lot like this. Right, sorry, just one more second. A lot like this. So this was a real site analysis that Adi Asmani has posted a while back, where it turned out that there were just like big heavy dependencies, duplicated 40 times over, sent to the user 40 different times, 40 different ways, really slowing down the site. And it's really easy for, if you just aren't paying attention or aren't actually looking, for this to happen. So definitely, if you aren't doing this, try to start with some regularity. It's a really good way to catch just silly, kind of complicated but weird errors. Now, for my last question, God, you know what? Actually, does this look familiar to anyone else? I'm getting a weird sense of deja vu. Is that Create React App? Is that you? That is you. Create React App, what are you doing in my talk? You're for web apps. This is a conference talk. Silly. Huh. It actually brings up something very important though, because as I was coming up with this really stupid bit that I just put you all through, I actually got curious about how much time I'd spent waiting for Webpack, how much time I'd spent waiting for any bundler. And I actually, to the point where I went back through all the apps I'd worked on over the last, say, 3 years, and profiled them, or asked a coworker, ex-coworker, to profile them for me, so don't tell anyone. But got the stats on those, and this is what I saw. And this wasn't really surprising to find out, right? These are the apps I'd worked on over years, but to see it laid out like that, that's a lot of time spent waiting for dev tools. The worst offender taking almost a minute to start up, and then over 10 seconds on a per change basis to update. And funny enough, number 4, a NEJS app. So if anyone's using Next, way to go. Very good performance story, apparently. But this is what I want to talk about today. Because you've seen the talk title, so you know the bad news. This isn't a talk about how to use Webpack better or write or configure. That's not what this talk is about. It's actually really not even about Webpack at all. It's about bundling in general. It's about why we do it, how we even got started doing it with the regularity and the frequency that we do, and what that's costing us. And then I want to look forward into what we can do about bundling. Do we still need it in 2019? Is there anything we can do to maybe move away from it? Has JavaScript moved to the point where we still need this? Is it still essential? Is it still required? So that's what I want to talk to you all about today. My name is Fred Schott. I work on a project called Pika. Pika's goal is to make the internet faster. That's full stop, that's the goal. And we do that by moving JavaScript forward. So by making modern JavaScript more accessible and easier to use. Now, has anyone here heard of Pika before this talk? That is awesome. That is really cool. For everyone else, this is going to be exciting. Pika started as a website, just a place where you could go to find modern packages. So think of this as like NPM, but with a filter on top of it for high quality, modern, and web-focused packages. This is how it started. It basically fixed that problem. How do you find packages written for the modern web? So when I say that, I mean it's an ES module with a module entry point. But if that's gibberish, I'll get into that later. So just think of it as like a modern web-focused package. It has a really nice search feature, along with a cool little badges if it's including types. It shows you the size of the package, so you can know what it'll actually impact your web app size and your performance. So it's really focused on the web developer. And also, you can drill in and get really cool information, so cool stats on the left, or README. We also have a way to browse the source code, which we just launched this week, including a REPL, so you can actually run the package inside this inside the page without even installing it. So try it out before you use it. As well as a CDN where you can actually pull this package from remotely. So a lot of cool features, all revolving around this kind of what you can do with modern packages. Now, this solved the discovery problem. How do you find these packages? OK, great. But again, we want to make the web faster, so discovery is only half of it. So we've also started working on a set of tools to work with these modern packages. And I don't have time to go through all of them, but I do want to talk about one in the context of this graph. Because I feel like we've gotten to know each other pretty well now. I can say this with some comfort. These numbers are really bad. I'm very embarrassed to have done this. Right? We're not Java developers. We're not compiling C. We're allegedly writing a language that can be shipped to the browser and it runs it directly. So what's the story here? And what I want to explore is there a way that we can get this close to this? And this is such an order of magnitude better that I have to zoom in on the chart. This is our goal for performance. Is there a set of tools out there that we could create that doesn't limit what you can build? You can still build the same great web apps, but in 2019, you could revisit that set of requirements to actually move faster, to have maximum 1 second of time to start up your dev environment and 300 milliseconds max time to on per change recompile. So I'm going to show you towards the end of this talk a tool that we use today in production to do this. It's not vaporware. It's not a hacky prototype. It exists today for modern web development. But before we do that, I want to give some context, which is why do we need web bundlers, right? I said it's this required thing. What do I mean by that? And why did I call this talk Reimagining the Registry if all I'm going to do is talk about Webpack for 20 minutes? I apologize. The answer to both questions is NPM. NPM is the reason that we originally found bundlers, and it's the reason that we really need bundlers still today. The reason why almost every hand went up when I asked, had you used Webpack? To really answer that question, I have to go back to 2009. So go back 10 years, Avatar is out, Bieber's doing something, I'm sure. Who here was doing web development around 2009? Show of hands. OK, so if you raise your hand, look away. This next slide is very shocking. This is what we did, and it was chaos. It was anarchy. You included the scripts in an order that mattered. They would implicitly depend on each other, so God forbid it was in the wrong order. A mess, a complete mess. Now, if you were smart, you would bring your own module system to the table. So you'd bring something like AMD, which let you define your imports and your exports in the context of this define function. It gave you some structure. And this worked. It looks a little hacky, but it really worked because bundling for production at the time was this really simple story of just basically string concatenation. You basically take all your little individual JavaScript files and combine them into a bigger JavaScript file. And so calling a function like this kind of made sense, right? Because you could just imagine these all next to each other and all just kind of working. Around that time, Node was getting started, and they were championing something else. They were championing something called server.js, which was later renamed to common.js. So this is a little less boilerplate, a little more straightforward. You require your dependencies, and you attach your exports to a module object. This was really cool. They really liked it. It worked really well. It was a little bit more simple and straightforward. The problem is that this would never work on the browser, right? Because what does the browser do when it gets to that first require function? It says, OK, I got to load cart library. I'm going to go out and, well, first of all, where does it look? And then what does it do while it's loading that file across the network? Does it just block the whole app? Does every file have to be loaded one at a time? That would never work. The CommonJS, the community, they knew this, but that was their goal. It was more server focused where you could look things up very quickly. If you're missing a file extension, you would actually try a bunch of different ones. So that was kind of an intentional split on their behalf for just ease of use. The problem there was that now you have two JavaScript communities doing two different things, right? Or they're doing the same thing, but different languages. They can't work with each other. They can't share the same packages. It was really the Node people who figured out how to bring those two groups back together with something called Browserify. Did anyone here use Browserify kind of back in the day? Yeah. This was like the first modern bundler, kind of gave way to Webpack and what we all use today. The idea being that, well, if loading your dependencies over the network is the issue, what if we just bundle all the files together? You're already doing that in production anyway. Just do it at dev time. And then that lookup, all of a sudden, it's just looking something else up in memory. That'll take no time at all. So it basically goes and finds out your dependencies and stitches them into one big JavaScript file. And obviously, that's gotten smarter with Webpack and code splitting. But that was the original kind of intention. And this let everyone use a single module system, right? So people love this because now you can use NPM, you can use this whole suite of packages. NPM went on to become the biggest package registry in ever. This was a big deal, and it really worked well for just code sharing in general. The problem there, and the kind of concession that was made that I don't think anyone really realized at the time, and I think we're still coming to terms with, was that the web ended up adding tooling to access NPM, to access this one shared ecosystem. And definitely a worthwhile concession to make, but it's ended up kind of affecting the growth of JavaScript in a lot of interesting ways. So I'm going to talk about it in a little bit, but this wasn't the web and Node coming together to build a single ecosystem. This was Node inviting the web into their ecosystem and saying, yeah, just by the way, do tooling, and that'll help you use the packages that work for us. So I'll talk a little bit more about that, but just keep that in mind for this next section. Okay, it's 2019. I don't need to describe 2019 to you. You're all in it right now. It's a dumpster fire. We're getting through it. We're just barely hanging on, but we're here. There's a new ES module system, like a native module format. So the smarty pants at Microsoft and Firefox and Chrome and Mozilla and Google, I think I named the same companies like 3 different times. But the idea is that they all got together and created a native module system. So this is something that the actual browser would understand itself. It has the kind of straightforward explicitness of CommonJS, but it actually can work on the web. The browser can go and find these dependencies asynchronously because it can just read the format. So this kind of has something for everyone. It's really explicit. And what's great is that bundlers can use that to their advantage. So bundlers are able to analyze this code on the right much, much better. So they can actually do dead code elimination and tree shaking much more efficiently because it's just a more explicit syntax. So yeah, this came out, I think, 2016. It was ratified. And in the last 2 years, every browser, modern browser that's been released has had it. TypeScript uses a syntax much like it. Bundlers support it, Babel, everyone. You're probably writing code in this format today. The one holdout, or significant holdout, has been Node. So obviously, it's very hard to move an entire ecosystem from one module system to another. And Node has certainly been trying, but it's been taking them a long time to move away from CommonJS. It still isn't supported today. It is experimentally supported behind a flag. Hopefully, it launches soon. But that's the kind of state of things. And this is where that concession comes back to bite us, because Node uses it, and because NPM is Node's ecosystem, we're all still using CommonJS, or we still at least all have to support it. Any package you get from NPM is built for CommonJS, for Node. Some of the better ones will go out of their way to do something like have a module entry point, which is what I meant by those modern packages. They'll create a second, basically, build. But essentially, we're all still stuck supporting CommonJS, at least until Node adds support. And then still, there's a million packages that are legacy, that still exist and probably won't be updated. So coming to terms with that. What that means is that we still need to handle CommonJS. We still need to handle a module system that doesn't work in the browser for the foreseeable future, which means even with a modern syntax that we're all writing ourselves, when we get into NPM land, it's still this Wild West. So that's disappointing. I'm sad about that. The 3 reasons for that, even if you're using all packages, all dependencies that are ESM, you still have to worry about a modern package that internally is depending on CommonJS. So it's fine, but its dependencies are still out of date. Bad imports that your bundler would have handled, so package name. The browser actually doesn't support importing by package name, at least not yet. So it only supports full paths that can be resolved. Because again, where would the browser look if it just saw cart library? Or if it doesn't have a file extension, how does it know which file extension to use? And lastly, there's just these like Nodisms in the community. Again, because we've been using bundlers, even web packages fall victim to this, where they'll just pull something from Node, which a bundler would normally fix for you. So importing from URL, that's not a real thing in the browser either. That's a Node thing that we've all adopted. So because of these 3 issues that are all over the community, all over the ecosystem, it's very hard to use modern packages just directly to send them to the browser. So that tool I mentioned earlier is called Pika Web. And its job is to help you run NPM packages in the browser without a bundler, without a traditional web app with bundler. And I'll show you what I mean by that. So you have your Node modules, and that's this kind of Wild West, right? You have these different packages that you know to be web-friendly, modern. What Pika Web does is it takes that installation, and it actually turns those packages into single JavaScript files. So if there's any CommonJS in your Node modules tree, it gets pulled in, so it doesn't have to worry about loading it. If there's any incomplete package imports, or imports by package name, it'll pull those into these single files, which lets you basically import from a package that exists as a JavaScript file, which does work on the web. So what you can do and ship directly to the browser is ESM code that you import from a path, and you write your own code to import from a path. So this is code that exists today. The first Pika website was built using this model, where there is no app bundler. I'm just writing JavaScript and shipping it to the browser and importing these dependencies as files. So this becomes just a thing of the past, right? When every dependency is a single file, there's all of a sudden you don't really have to worry about what happens if this thing is needed in multiple bundles or multiple routes. It just exists. Your browser caches it. The next time you need it, it exists. It doesn't change across deployments. It just exists, and your users have it kind of pre-cached. Versus if you have a single bundle every time you deploy, it all gets thrown out because it's a whole new bundle. So really good for multiple visits for efficiency in that way. And if we go back to this graph, when there's no build step in that way, when there's no bundle step, I'm just shipping directly to the browser. I mean, the start time is just however long it takes to get my local static asset server set up. And there is no recompilation, it's just JavaScript. So there's some really cool performance. This unbuilt kind of world is getting a lot of attention because it's just like, oh, I click save and my browser refreshes and the whole site's just there with the update. You iterate really fast. If that sounds like a little too far for all of you, that's totally fine. I actually recently added Babel and added TypeScript to Pika, so that's a part of the build step now. You can still have a build step. This isn't saying, it's bundler or nothing. What you can do is you just have a build step that isn't focused on bundling, it's focused on transforming a directory. So Babel, TypeScript, these were all tools that were created to transform directories, for your source directory to a lib directory, right? And so PikaWeb even comes with a Babel transform that takes this package name and turns it into the thing you see above, which is a full actual path that would run in the web. So you can keep writing much more friendly package names, and then we'll just, through the build step, go do that. So this still follows because we're not having to bundle and recompile multiple files. When you change a file, you recompile that file, and you're good to go. TypeScript and Babel are very much in the world of hitting this performance goal. TypeScript even has this today with incremental mode. So just every time you start up your build and run it, it just starts up where you left off. And Babel doesn't have a incremental mode, but they all have watch mode. So certainly they can hit that 300 milliseconds on the recompilation time. So the one question we get asked a lot about is, well, what about CSS, right? That's the one thing that Webpack's really good, and images as well. A few of those non-JS assets that you kind of import as JS, you're kind of tricking Webpack into doing something that isn't really a JavaScript thing, it's a Webpack thing. There are plenty of, so just what about CSS, but what about blank? This kind of applies to that, where there's these libraries out there that are specifically for this world. So CSC is a really cool one from Luke Jackson, where it'll just basically turn any CSS either inlined or from a remote package, a remote file, and turn it into a class name so you can just return that. Really cool. It basically just solves like, what does CSS look like when you're not bundling it specifically? So for the first time, you don't need a bundler, right? That's really what this is about, where if you see this talk and at the end you're like, Fred, this is crazy. Thanks, but no thanks. I'm good with Webpack. I put in my time. This is too wild. Come back later. If that's you, that is totally fine. This is not about saying one way is right and one way is wrong. This is about choice. And the idea that for the last 10 years, essentially, we've been forced to use bundlers, right? It's been a way to make this code that didn't run on the web, run on the web. The idea is that we now have a module system that will run on the web and is really easy to write. The one thing we still need to handle are our dependencies. So you can use this tool at install time, not at build time. Run it once when you install and you're good to go. And you can then continue to write modern JavaScript that will run in the browser on your side, or use a build step or anything. But you can just kind of not use a bundler, or you can not use a bundler until you're ready. So you can just add a bundler later. Maybe you're worried about performance in production. Maybe you just want a cool Webpack plugin for whatever reason. It's all on the table. I want to end on this piece by Chris Coyier that talked about a great divide in the community. So definitely ending on a not at all controversial note. This got a little bit of activity when it came out, but it was a really important discussion. The tagline sums it up pretty well. 2 front-end developers are sitting at a bar. They have nothing to talk about. And he went out and interviewed different web developers to try to get at what he saw as a growing divide in the community. So he saw the community splitting into 2 groups. One group basically focused all on JavaScript, and the other group on everything else, so HTML, CSS, design. He saw this divide happening. And you don't really have to look too far to find a culprit there, right? I don't think it's too much of a stretch. CSS and HTML, they haven't changed dramatically in the last 10 years, right? It's probably JavaScript, right? JavaScript has changed immensely, and it's kind of our entry point into the app. So you have Webpack, and you have all these tools, you have all these libraries. It's a very complex world that we've found ourselves in 10 years later. There's even a term for this, JavaScript fatigue. The idea that it is exhausting to keep up with JavaScript because there's so much development and new tools and new libraries and new frameworks. And this isn't just anecdotal. This is actually backed up by data. NPM does a yearly developer survey, and they looked into this, and they said that all of our survey respondents, they use the word all. I hope intentionally, I hope they know that meant all, but all of our survey respondents would like to see less tooling, less configuration required to get started, and better documentation. So if you bring these two problems together and view them together, what you see is an entire group of web developers being alienated from the most powerful part of the web platform. What this is all about is making it easier to do development. Simplifying our stack so we can spend less time on configuration and tooling, lowering the barrier to entry for new starters, new people entering the industry, making it more inclusive so it's easier to get involved, and just generally spending less time worrying about our stack and more time building things that matter. So please check out Pika. It's a really cool project. We're really focused on this kind of stuff, and thank you all very much.